All right, we're going to talk about arithmetic sequences. First, let me start off. We actually touched on this in Unit 1, but we're going to dig a little deeper right now. If we're talking about arithmetic sequences, first we need to make sure we remember what a sequence is. It's really just a list of numbers, right? If you have a list of numbers, you can call it a sequence. Now, when that list has specific characteristics, you can call it a specific type of sequence. So there is a such thing as an arithmetic sequence. That's when there exists so it's a sequence with a common difference. All right, not a common ratio. That's a different type of sequence. In fact, let me write that down. That's called a geometric sequence. A geometric sequence is when you have not a common difference, but it's a sequence with a common ratio. So this ratio is you're multiplying some stuff. When there's a common difference, you're not really multiplying stuff, you are adding stuff. Okay? It's better when I do an example. We are going to focus on arithmetic sequences, but I wanted to let you know about geometric. For example, 2, 4, 6, 8, 10, ... That is a list of numbers. And I noticed that when I look at the common difference, that means if I go 4 minus 2, I get 2. When I go 6 minus 4, I get 2. When I go 8 minus 6, I get 2. Let me write that down. When you look at it as 4 minus 2, you get a 2. Then you do 6 minus 4, you get a 2. You do 8 minus 6, you get a 2. You do 10 minus 8, you get a 2, on and on and on. Notice that this is it's the same exact number. When I take the difference between these two, the first one and the next one, when I take the difference between them, I get a common number. That too is called the common difference. That number is called the common difference. It is given by the letter D. Okay, so if you ever see a list and you can tell that you're increasing it by the same amount, you can tell me that that common difference is that amount. Now, it's nice if I had this list here, but sometimes you won't see that. You'll see what they call an explicit formula. There is an explicit formula for all, extra letter here. There is a such thing as this formula, a general formula, we call it the explicit formula for all arithmetic sequences. It is any term. Now up here, this is the first term, the second term, the third, fourth, fifth, on and on and on. Any term, we call it a sub n. That is any term. What people will say, sorry, I'm just stumbling today. What you might hear people say is not any term. You'll hear them say the nth term. That means whatever the number is here and here. See that n? So the nth term, get rid of that thing. The nth term is equal to whatever the first term is. A1 is the first term. That's what that is. Plus, so you have 2, but you add to that this common difference every single time. This common difference every single time. And then you do that a certain number of times. If you have 10 terms, you do the first one, but then you should do it 9 more times. This is the 11th term, you do the first one, then you need to do it 10 more times. Well, the way we show how many more you do is not the same as just n here. You can't just write n because you'll have n plus 1. You actually do n minus 1. So this right here gives you the explicit formula. All right. So I could ask you, for example, to give me, if I gave you an explicit formula, let's just say that a sub n is equal to 3 plus 2 times n minus 1. I could ask you to give me a sub 3. All I have to do is take this 2, put a 3 in here, and plug it in. So that's going to be 3 plus 2 times 2, 3 plus 4, 7. So if I were to write out the list, the third number in that list would be 7. The first number would be 3. All right. And if I wanted to